So let's look at your workbook page here. You're going to need a piece of graph paper because I want to show you how to do like questions 4 through 11. So I'm going to just choose something at random. And you'll notice that all of these points that they're giving you, they tend to create these right triangles. So if I can get a plain sheet of paper. So I'm going to create a coordinate grid. And I'm going to choose number, let's just do number 4. Because they're all pretty much the same. So let's do number 4. So number 4, you're going to plot A, 1, 3. B, 4, 3. And C is 4, 2. It's a really tiny triangle. Notice that it's a right triangle. Where do you anticipate the circumcenter is? On the hypotenuse. So if you find the perpendicular bisectors to the legs, and they want you to find the circumcenter. So if I find the perpendicular bisector, it's really easy when the legs of your right triangle are vertical and horizontal. This distance here is how far? 3. So if I just go 1.5 away and draw a vertical line through there, and then this is 1, so I'm just going to go right halfway in between and draw a horizontal line. Then I end up on my hypotenuse. And so this right here is my circumcenter. And we're just going to make a best guess, because that's not a nice happy point, is it? About what point do you think that is? Where is my, and I purposely drew my perpendicular bisectors to hit the x and y axis. So
I would say 2.5.
So we would say, and let's call this point D. So D is about 2.5. What? 2.5. Agreed. Now, how can we find that exactly? We could use a distance formula from A to C. We're not going to spend time to do that today. So there's that question. The Pythagorean theorem is just going to get you the distance from here to here. It's not going to get you the actual order of pair. So, we don't need the distance formula. Couldn't we just do the midpoint formula? What was I thinking? So A is 1, 3. So your midpoint for AC would be take your A and your C. So we're going to take A and C, and we're going to average the x's. So 1 plus 4 divided by 2, and average the y's. 3 plus 2 divided by 2. So our midpoint for AC is 5 halves. Isn't that 2.5? And 5 halves, isn't that 2.5? We did pretty good, didn't we? Oops, sorry you couldn't see that. Then, here these are pretty easy. Name the point of concurrency of the angle bisectors. How hard is that? Well, look at 14. There's a lot of points in there. It'd be easier if you took a highlighter. Here is, notice that there's, like, they've got 2 little angle bisectors going here. This is the angle bisector from point S. And isn't this the angle bisector from point R? Where do those intersect? At W. So W must be the point of concurrency. So be careful when they have a whole bunch of lines in there. So you find the point of concurrency to 13. I use a highlighter. Just saying. Because what that highlighter does, it makes everything pop out at you. Where is the point of concurrency? Where do those 2 lines intersect? At H, at J, or at E? What point is on both lines? E for Edward. So E is your point of concurrency. So you can see it can get a little confusing depending on how they give it to you. Why are you packing up? I have 2 minutes. We're not packing up. It takes you 30 seconds tops to pack up. Then you're going to come to questions like these. Look at what they've given you. With an angle bisector, so these are angle bisectors here, the distance that the in-center is from the sides of the triangle, those pieces are equal. So like on this one, I know to set 3x equal to 2x plus 5. So all of these are on this particular question, are all angle bisectors. So like on this one, 21, this is the distance here that this point, the in-center is from the sides of the triangle, so you can set those pieces equal to each other. So be really careful when you're looking at multiple items in your triangle. All right, so I will leave you to do your homework tonight. It's listed on the board. I will be collecting it tomorrow.